In our daily lives, then, we are often confronted with the need to calculate motion and determine an object's rate of speed. Velocity is a term used by scientists to describe an object's speed in a particular direction. Consider this riddle, which seems confusing, but is actually quite easy to figure out. Two boats leave the same dock at the same time, traveling at the same average speed. Yet they end up in different locations. How can this happen? The two boats traveled at the same average speed, but they were simply traveling in different directions. This simple question helps focus on the fact that objects possess both speed and direction, a condition known as the velocity of an object. An airplane might be described as having a speed of 700 kilometers per hour, but more specifically, its velocity might be 700 kilometers per hour north. Velocity is speed in a particular direction, so that this airplane going north at 700 kilometers per hour has both speed and direction. Another way to understand velocity is to think of it as the rate of change of an object's position. For example, suppose this plane changes direction from north to east. Even though it still flies at the same speed, we refer to its motion as a change in velocity. Velocity, of course, is an important factor in many ways. Meteorologists, for instance, must know the velocity of air masses to correctly forecast weather. And for air traffic controllers to guide planes safely, they must know the velocity of each aircraft in their region.
For a moment, let's consider velocity from another perspective. Suppose you're on a bus traveling north at the rate of 20 meters per second, which means you and the rest of the passengers are also traveling at 20 meters per second. Now, imagine yourself getting out of your seat and moving to the front of the bus at a velocity of 2 meters per second north. Consider this question. Are you still moving at the same velocity as the bus? No is the answer here. Velocities can be combined to form a resultant velocity. So if the bus is traveling north at 20 meters per second, and you are moving to the front of the bus at 2 meters per second, the resultant velocity for you is 22 meters per second north. Let's change the situation. Suppose you get out of your seat on the bus and you move to the rear at a rate of 2 meters per second south. Now what is your velocity? In this case, you're combining velocities for opposite directions. So you subtract the smaller velocity from the larger, and the resultant velocity becomes 18 meters per second north.
When scientists launch a spacecraft, like a space shuttle, in which direction do you think they launch it? With the rotation of the Earth or against it? Spacecraft get an extra boost when they're launched in the direction of Earth's rotation. Because our planet rotates at about 1,800 kilometers per hour, that speed is added to a space rocket's velocity. If the spacecraft were launched against the direction of the Earth's rotation, its rocket would require more power for blastoff and more fuel.